In an astonishing twist, NASA's James Webb Space Telescope has made a groundbreaking discovery that has left astronomers around the globe amazed. Just a few weeks ago, the telescope uncovered the oldest known galaxy in the universe. However, it has now detected something even more extraordinary: a supermassive black hole speeding away from its galaxy at an astonishing 4 million miles per hour. This latest revelation is sparking important discussions and raising numerous questions among scientists and space enthusiasts regarding its implications for our understanding of the cosmos. The James Webb Space Telescope was launched with the mission to study the earliest stars and galaxies in the universe, capturing breathtaking images of stars and galaxies dying just a few 100 million years after the Big Bang. We invite you to join us as we delve into the latest findings from this remarkable telescope. If you're keen to stay informed about the latest space news, be sure to subscribe to our channel, like this video, share it to reach a wider audience, and activate the notification bell. This latest discovery challenges current scientific perspectives on black holes. Traditionally, black holes are seen as massive forces that draw everything, including light, toward them. However, the black hole recently observed seems to defy this norm, exhibiting behavior unlike any other known black hole. Instead of pulling in light, this black hole appears to be fostering the creation of new stars along its trail. The trail of newly formed stars extends an impressive 200,000 light-years from the black hole, baffling scientists. A team led by Yale University's Professor Peter Bonda recently published their findings in the astrophysical journal Letters, which were later corroborated by NASA's Hubble Space Telescope. These findings suggest that the black hole triggers the formation of new stars when it interacts with gas and cools it, producing a spectacular wake of newborn stars behind it. But that's not the end of the story. NASA has also made an exciting announcement about a galactic merger captured by the James Webb Space Telescope. This massive merger of two galaxies can be seen glowing among other galaxies in the night sky. When two spiral galaxies collide, the event, known as ARP-220, produces a brilliant shine in the infrared spectrum, making it an ideal subject for observation by the James Webb Space Telescope. ARP-220 is classified as an ultraluminous infrared galaxy with a luminosity equivalent to 1 trillion suns, significantly outshining the Milky Way, which has a luminosity of about 10 billion suns. Located in the constellation Serpens, approximately 250 million light-years from Earth, ARP-220 is considered the brightest of the three closest galactic collisions to us. It is listed as object number 220 in the Atlas of Peculiar Galaxies. Around 700 million years ago, the collision of two spiral galaxies triggered a massive star formation explosion, creating a dense region spanning about 5,000 light-years, containing roughly 200 large star clusters. This compact area holds as much gas as the entire Milky Way. Prior radio telescope observations have identified more than 100 supernova remnants within a span of fewer than 500 light-years. Later, the Hubble Space Telescope revealed that the two galactic cores are separated by 1,200 light-years, and each has a rotating ring of star formation emitting brilliant infrared light. The latest images from the James Webb Space Telescope highlight this spectacular galactic merger, with faint tidal tails extending from the merger's edges, reflecting the gravitational pull between the two galaxies. The reddish and orange streams represent scattered organic material in ARP-220. Another remarkable discovery has left scientists perplexed: the detection of primordial galaxies at the edge of the universe. At first, some researchers questioned their authenticity, suspecting they might simply be nearby galaxies in disguise. To confirm their findings, they shared the data with other scientists worldwide. To their amazement, the James Webb Space Telescope confirmed that these ancient galaxies are indeed real. Thanks to this revolutionary telescope, astronomers can now observe the oldest galaxies ever detected. Light from these galaxies has traveled over 13.5 billion years to reach Earth, offering a rare glimpse into the universe's distant past. These galaxies were discovered when the universe was only 350 million years old, shedding light on how rapidly the first galaxies emerged. Spectral data confirmed that these galaxies are located at the very edge of our observable universe, with some even beyond the reach of Hubble's observation. This discovery is significant as it validates one of the primary objectives of the James Webb Space Telescope, to study the early universe through light that has been journeying for more than 13.5 billion years. The telescope's ability to measure extreme red shifts allows astronomers to examine the universe's earliest galaxies in infrared, offering a deeper understanding of the cosmos. The excitement surrounding these discoveries is palpable, as it marks a crucial milestone in both the exploration and understanding of the universe's evolution. This discovery has profoundly impacted our view of the universe, prompting NASA to consider the development of even more advanced telescopes to further explore whether our understanding of the Big Bang theory is accurate. Data from the Webb spectrometer and near-infrared camera has revealed that 4 of the 6 primordial galaxies detected exhibit extreme red shifts, suggesting that the Webb telescope is observing them as they appeared 300 to 500 million years after the Big Bang, lacking heavy elements like carbon. This is astonishing, as the universe is thought to be 13.8 billion years old, and the existence of these galaxies challenges our understanding of the early universe. The discovery has led to growing concern within the scientific community, as these findings challenge the current cosmological inflation model and the Big Bang theory, which has unresolved issues, such as inconsistencies with the laws of thermodynamics and a lack of a clear explanation for the Big Bang's origin. Furthermore, the James Webb Space Telescope is uncovering galaxies that are almost as old as the Big Bang itself, raising fundamental questions about the universe's origins. Theoretical physicist Michio Kaku has stated that the discovery of these ancient galaxies has forced scientists to reconsider everything we thought we knew about the beginning of the universe. Previously, these galaxies were believed to be less advanced than the Milky Way. However, new findings suggest that these galaxies may be far more developed than previously thought, prompting scientists to question if the current theories regarding the universe's creation are accurate. The identification of 6 galaxies, which existed only 500 million years after the Big Bang and are up to 10 times larger than the Milky Way, raises the question of how such vast, young galaxies could form so rapidly. Kaku further explained that it typically takes billions of years for a galaxy like the Milky Way to form, making the discovery of such large primordial galaxies even more puzzling. This discovery may require us to rewrite textbooks on the origin of the universe. The findings from the James Webb Space Telescope challenge our understanding of the Big Bang, placing scientists at a crossroads. In spite of these uncertainties, NASA has recently shared an intriguing update about a galaxy cluster that exists just 650 million years after the Big Bang, adding another layer of mystery to the puzzle. Astronomers have analyzed the data and concluded that this young cluster is expected to expand in size and eventually resemble the colossal Coma cluster, A1-1656. The location of this cluster is unique, as it lies in an area where galactic evolution is accelerating. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of 7 galaxies in this cluster, giving them confidence that these galaxies are bound together in a protocluster. To put this in perspective, NASA scientists have compared these distant galaxies to small drops of water flowing in different rivers, which will eventually merge to form a vast, powerful river. This comparison highlights the ongoing process of galactic formation. Clearly, what we once believed about the Big Bang no longer aligns with these findings. However, more data from the Webb telescope may ultimately confirm or challenge the theory. It remains to be seen whether the Big Bang did, in fact, occur, and if so, what triggered it. Regardless, the truth may be closer than we think. As the James Webb Space Telescope continues to unravel the mysteries of the cosmos, each new discovery adds more depth to our understanding of the universe's origins and evolution. These remarkable findings prompt both excitement and caution in the scientific community. They force us to reassess the foundations of modern cosmology and challenge long-standing theories that have shaped our understanding of the universe for decades. The telescope's ability to peer further into the past than ever before is pushing the boundaries of what we know, and it's clear that we are just beginning to scratch the surface of these profound revelations. With these latest discoveries, astronomers and physicists must now confront the possibility that the models we have relied upon may need significant revisions. For instance, the discovery of galaxies appearing within just a few 100 million years after the Big Bang suggests that galaxy formation occurred at a far faster rate than previously believed. This raises the intriguing question of whether the conditions that allowed such rapid growth were different from what we thought, or if there are factors we have not yet accounted for. Additionally, the James Webb Space Telescope's findings are forcing a reevaluation of the very nature of dark matter and dark energy. These elusive forces have been a central part of our cosmological models. Yet the discoveries made so far suggest that our understanding of these forces may need an overhaul. The acceleration of galactic evolution in the early universe, as observed by Webb, may indicate that dark energy played a much larger role than previously thought, or that new, unknown forces could be at work. For scientists, this presents both an opportunity and a challenge. The opportunity is the potential for unprecedented discoveries that could reshape our entire understanding of the universe. The challenge is how to incorporate these new findings into the existing framework of cosmological theories. As more data pours in from the James Webb Space Telescope, astronomers will continue to refine their models and try to make sense of the new realities that are emerging. The implications for future space exploration are also significant. With the James Webb Space Telescope now able to peer into the deepest reaches of space, it is providing us with an unprecedented view of galaxies, black holes, and star-forming regions that were once thought to be beyond our reach. This opens up new possibilities for future missions and technologies aimed at exploring these distant and ancient regions. The discovery of galaxies that formed so early in the universe's history, for example, may lead to the development of even more advanced telescopes capable of studying the conditions that led to their formation. Moreover, these findings have the potential to influence the search for extraterrestrial life. Understanding how galaxies and stars formed in the early universe could help scientists identify the conditions under which life could emerge elsewhere in the cosmos. If life could arise so early in the universe's history, could it have appeared in other places too? These discoveries might be the key to answering that age-old question. As we continue to explore these mysteries, it's important to remember that the discoveries from the James Webb Space Telescope are not just advancing our knowledge of space. They are reshaping our understanding of time, matter, and the fundamental forces that govern the universe. With each new observation, we move closer to answering some of the most profound questions humanity has ever asked. What is the nature of the universe? How did it begin, and how will it evolve? Is there life beyond Earth? These questions may not have easy answers, but with the data coming from the James Webb Space Telescope, we are one step closer to unraveling the mysteries of the cosmos. As the telescope continues to explore the vast reaches of space, the discoveries it makes will likely continue to surprise and challenge us. The more we learn, the more we realize how much there is still to uncover. The universe is vast, and our understanding of it is still in its infancy. But with each new finding, we get a little closer to understanding the ultimate nature of reality itself. In conclusion, the James Webb Space Telescope has already made remarkable strides in advancing our knowledge of the universe. From the detection of ancient galaxies to the observation of black holes with behavior unlike any seen before, the telescope is pushing the boundaries of what we thought was possible. As scientists continue to analyze the data and make new discoveries, it is clear that this is just the beginning of a new era in space exploration. The revelations from the Webb telescope promise to shape our understanding of the cosmos for years to come, and we can only imagine what the future holds as it continues its mission to explore the furthest reaches of space and time. What are your thoughts on these groundbreaking discoveries? How do you think they will change our understanding of the universe? Share your opinions in the comments section. We would love to hear your insights.